Hey, welcome everybody, it's Caleb. In this video, we're going to be talking about 25 Python tips and tricks. Now, this is a follow-up to the previous video, 50 Python tips and tricks, which have some more of the beginner tips. So if you want to get a notebook with all of those tips, I put a link where you can get those for free in the description. Now, before we jump in, I just wanted to give you a friendly reminder that this is the last day to register for the Python Bootcamp. At midnight tonight, it'll be closing and you won't be able to register again until it reopens sometime mid next year. If you happen to be watching this after it's already closed, no worries, you can go to the webpage and sign up to be notified when it opens again in the future. And with that, let's get started. My first tip has to do with functions changing parameter values. So in this situation, we have a primitive type, an integer that we pass to this calculate function, which then raises that value to the fifth power. But when we print the data afterwards, it stays exactly the same as the value 5. So these changes didn't persist outside of the function call. Now this is considered proper behavior. However, there are scenarios when you might want to change this. There's a few things you can do. You could return the new value, or if you actually want to be able to change primitives inside of the function, you can wrap it in an object. The easiest way to do that is just to put it in a list, and then all you have to do is change the first index of the list. And now we have 3125 in a list. So you need to get that first element. And there we go, 3125. That's the first technique. The other technique is you can use a class and then make an instance of it. So let's back up and we'll go up here and create a class container. And we're going to define the init method. And all we're going to do is say self.data is data. Then when we create this, we're just going to create a new container with the value 5, pass in x, and print x.data. Inside of the function, we just say param.data and run this and we get 3125. So lesson learned, object data can be modified within a function and those changes persist outside of the function. The second tip is that if you have two objects, you can check to see if they are the same object in memory using the is operator. So for example, x is y, and this should give us the result false. It's important to understand this because they do have the same values, but they're different objects. My next tip is that you can add methods to a class dynamically. So for example, we can define a method, and we're actually going to override the equals method so we can compare these by value. This is going to take self and other. And then all we have to do is say return self.data equal other.data. Now to attach this to the container class, what we could do is to say container dot underscore eq is underscore eq. So the syntax is a little bit funky, but it should work and we still get the same result. In this scenario, it's not really that important to do it this way. We could just put that inside of the class, but just showing you that it is a possibility. If you don't have direct access to the class definition, you can add a method to that class. Now that you defined a method to compare by value, you can check to see if they have the same value by saying equals equals. And now running this, we get the value true. But keep in mind that these are not the same objects in memory because is returns false. And if you would like, you could pass in the ID of these to see what you get. Like this, and you can see these are two different values. This next tip is super simple. When you have a class, you'll often see parentheses here, and those are used for inheritance, but they're 100% optional if you're not inheriting from anything. If, on the other hand, you have a function with no parameters, you're still required to use those parentheses. So if I went up here and I said def do something and just tried writing code, we're going to get a syntax error, invalid syntax. So classes, it's optional, functions, it's required. In Python, it's really easy to get the current time. All you have to do is say from datetime, import datetime, and then you can print datetime.now. This is going to have the year, month, day, the time, and then microseconds. So if I keep running this, you can see these go up pretty quickly and the seconds go up, every second, which would make sense. You can access these individually with the associated attribute. So for example, we could assign this to a variable and then we could say print now.year and that'll give us 2020. Refer to the notes if you want to see all of the attributes. My next tip is that you can easily do a countdown or get the time until a current event in Python. All you have to do is say when you want the end time to be. So we can say date time and pass in something like 2020, and then we'll go with the 12th month, first day. Then all we need to do is subtract now from end. And running that, you got 2 days, 9 hours, and 44 seconds. You could very well do this in a loop if you would like. Using this technique, you can keep track of an elapsed time to time how long it takes to do something. So what I'm going to do is I'm actually going to change this time here to datetime.now and then create a loop in here for I in range, and then just put a really large number. We'll just go with 999,999,999. So that's going to take a while. And then to do nothing, you could just say pass. That's how you can create an empty loop in Python. Now let's run this. And you can see it took us 25 seconds and a bunch of microseconds. For this next tip, you can see we get the datetime.now 2 times in a row, and we're doing some subtraction. And this is going to be just a friendly reminder of some basics. So if we have this expression here, my thought was, hey, we're going to have a really small number of microseconds. So I'm just going to do the subtraction and then get dot microseconds. The problem with this is operator precedence. The dot microseconds is actually going to happen first. And actually, it's going to show this when I run this. It'll automatically space these out such that you can easily see it's trying to get the microseconds on now, which is a date time, and it doesn't have an attribute microseconds. However, if we throw in our parentheses here, run it now, you can see we get 10, 5, 22, and a very small number of microseconds like we were expecting. So now I want to talk a little bit about syntax, and you can see we have this working properly, but let's say we went back to where this was incorrect, and we got this attribute error. This is a runtime error, and this tip, I just wanted to call out the difference between a runtime error and a syntax error. This is syntactically correct. The expression just doesn't make sense because this microseconds attribute doesn't exist. This is a fundamentally different type of error than a syntax error, which, as we shown earlier, we could create a function and forget to put the parentheses. And this will actually be a syntax error where it doesn't even let you execute your code. So the syntax errors, those have to go to run the code. The runtime errors, they're going to happen when we hit that code, and they can be captured with a try and except. So we could say try except, and you can see it's going to print broken. Getting a random number in Python is really easy. You just say from random, import randint, and then you say randint and then give a range such as 0 to 10. And these are inclusive, so you could get 0 all the way up to 10 and any number in between. And then we'll just print this out, and you can see it seems to be working. When we're developing, there could be a scenario where we already have some name defined. So let's say we had a function randint, and for this, all I'm going to do is return 52. And we're trying to use that function, so we just invoke randint like so. Well, it's not going to work, and that's because this randint actually replaced our randint. So if you need to keep both, you can actually import this with an alias by saying as something else, such as r, and then you can invoke both options, such as r10 to 20. And you can see here we get 52 from our version of randint, and then we get 13 for this version of randint. For this next one, this is going to be the first exposure to generators and the yield keyword for a lot of you. And basically this allows us to create a function that's going to continually give us new data. A perfect example of this is generating some sequence of numbers, such as the Fibonacci sequence. So what we could do is we could create a function, and we'll just call it fib. And we're going to pass in the count of how many numbers we want to get back. And for the Fibonacci sequence, it's the addition of the 2 previous numbers in the sequence. So starting out, we're going to have A and B, and these are going to be assigned the values 0 and 1. Then what we can do is we can make a loop while count, and now we move up in the sequence. So A is going to become B, and then B is going to become B plus A. Now to do this on one line, it's really simple. We just say A comma B, and then take B plus A and put it at the end here. So that is the way to get the next numbers in the sequence. And then all we need to do is say count -1, so that way the loop doesn't go on forever. So how do we get numbers each iteration? We say yield A. So that is going to give us 0 the first iteration, then 1, and then 0 plus 1, and then 1 plus 1, and so forth throughout the Fibonacci numbers. Now to use this, we assign it to a variable such as f, and then we can pass in the count such as 100. And then what we do is say next and pass in f. So what we're going to do is we're going to print this value. And when we do this, we get the value 0. And every time we do this, we're going to get another number. So we'll do it a couple of times, and you can see we get 0, 1, 1, 2. And this is actually an iterable, so we can get these one at a time in a loop. So for example, instead of assigning it to a variable, we can say for I in fib, and let's say we just want the first 20 numbers. And then what we'll do is we'll just print I and separate them by a space. And running this, we get the first 20 Fibonacci numbers. In Python, integers are unbounded, which means we can make an integer as large as we want. And we can add this to another number as large as we want. And let's go ahead and print x, and you can see it appears to have worked. I'm not actually able to do the math on my head, to be honest, but what if we want infinity? We can get that using the math module. So what we'll do is we'll say from math import inf, and then all you have to do is print inf. And running that, it just looks like a word, but if you print type, you actually get float. And this is based off of what used to be float, and then you would pass in a string inf, and that would also be the same thing. And just as a side note, if you take infinity and you subtract 1 from it, let's get rid of this type here, we still have infinity. So we can use that to our advantage when we want an infinite number. Going back to our generator, if we wanted to generate unlimited Fibonacci numbers, well, we could get rid of this countdown and just say while true. Or what we could do is we could say fib inf and import that from math. So from math, import inf. Now, what we could do is we could just keep running them. And you can't clearly see it here, so let's put a little bit of a sleep. From time, import sleep. Sleep, we'll just do 0.5. And now you can see the numbers slowly appear. So you can see that this setup allows us to grab one piece of data at a time, which is nice in some scenarios. Other times though, we're going to want to get a certain number of elements up front. So what if we wanted a list of the first 20 Fibonacci numbers? I'm going to show you how to do that. We'll get rid of this. We're not going to need these imports anymore, so we can take this function, put it to the top, and we're going to use list comprehension. So for I in fib, and we'll just grab the first 20, and we'll just grab I by itself, and we'll just assign this to a variable for readability and print all. And there you go. That's how you get the first 20 elements. Now this all works because of this count here, but it's a little bit cluttery, and I'm going to teach you a different solution in the next tip where we no longer need to use a count variable. So to get rid of this count variable, we're going to use a module called itertools. And this will give you a lot of different tools for working with generators, one of which allows you to basically set a limit on how many elements you want to return, but you don't have to define that logic inside of the generator function. So what we can do is we can just say while true and get rid of this count and decrement here, and we no longer need to take count as an argument passed in. So how do we actually use the tool though? Well, we can get rid of this line here, and we're going to say itertools dot islice or islice, which I'm pretty sure it's the first of the two. And then we'll just get our generator and pass in the number of elements we want. And what we're going to do is we're going to print this as is, and you can see that we get an islice object. But we need to convert this to a list, which is actually really easy. Just surround this in parentheses and pass it to list, and there you go. So to get the exact same results as what we had in the previous tip, there you go. So now we're going to be using a very simple linked list class, which basically has an initialized start node, and then each node points to another node. And we made a sequence of 5, 10, 15, and 20. And what I would like to do is to say something like for node in linked list, print node.data. But when I do this, we get linked list object is not iterable. So to iterate through custom types, what we can do is we can define an underscore iter method, and then we can use the yield keyword to get one node at a time. So we will start with node being self.start, and then we're just going to keep moving that node up until there's no more nodes. So we'll say while node yield node, which will allow us to jump back and forth between this execution and our for loop. And then all we have to do is say node is node.next. So now when we run our code, we get 5, 10, 15, 20. So each iteration of this loop, it jumps back to this position right here and gets that next node until node is none. So if you were given a list and it was empty, you could check if it was empty by saying not data. And this runs as true. So this evaluates whenever the list is empty. If we put something in here, it's going to be false. But what happens if you try this on a custom type, such as our linked list? And to create an empty linked list here, I'm just going to say none. And we'll check against our linked list, but you can see we still get the value false. So something's not working right here. In order for this to work, you can override a method length, which is underscore underscore len. And here you can define behavior to see how long this linked list is. If this returns 0, then not linked list will evaluate to true. This actual method will be pretty simple. We'll just say count is 0, and then for I in self, which is going to use our iter method, we will just say count plus equal 1. Once we're done, we're just going to return the count. We'll save and run this, and you can see we now get the value true. And if we threw a node in here with the value 5, we get false, which is exactly what we want. So if you're given these two lists, you can combine them using the zip method and then just pass names and points. However, this is not going to be in a format that's easily read, so if you print it, it's just going to say zip object. So the easy fix for this is to just pass it to list, and it'll convert it to a list of tuples, where each value is associated with the equivalent position in the other list. So if you wanted to take this list of tuples and for some reason convert it to a list of lists, we could do list comprehension. So we're going to replace this line here with a list comprehension. So we'll say for item in zip and pass in names, comma, points. And then what are we going to do with each item? We're just going to say list of item. We'll assign this to a variable zipped, and then we'll just print zipped. And running this, we got a list of lists. So what happens if we add an additional item in here? Well, you can see that does not show up in the output. So if you need to preserve all of the data, that's where itertools can come in and save the day. So what we're going to do is we're going to say from itertools import zip underscore longest. And that's going to go all the way to the longest thing that you're zipping. And then all we have to do is underscore longest here, run this, and you can see that last one is added at the end with an associated none. If, on the other hand, we had more numbers than names, it's going to do the same thing, where for the names, we are left with a bunch of nones. So whichever you prefer is up to you. So here I have this method zip list, and it's going to let you choose between the longest or the normal default short version of zip. This is to illustrate the fact that we can have default parameter values. So by default, it's going to be true and go for the long version. So to see how this runs, here I have some code down here. We have names and points, and we invoke zip lists, and we get the result by default, the longest. But we could go in here and pass in another argument and say longest is false. And in that situation, it's going to go for the short version. Building upon the ability to assign default values to parameters, we can actually do named parameters and pass them in different orders. So let's say these had default values as well. So we'll get rid of this for just a moment. And now we can pass these in any order that we want. So we could say longest is true. And then list2 is, we'll just say one element, Caleb. And running this, and it works. So having default values allows you to pass them in by name. In an upcoming video, we might go over all of the different possibilities for arguments and parameters, because you can have positional only, keyword only, and there's just so many different combinations, but this is a good intro. Study it up more if you need. You can easily programmatically check what version of Python you have by saying from platform import Python version with an underscore there, and then just invoke Python version like so, and you can see we get 3.9. You can also easily do this in the terminal. However, that's not programmatically. If you need to check what version of Python the person running this script has, you can do that in code like so. So that includes my 25 tips for this video. Lots of different things. Let me know if any of these were surprising or helpful to you, and hopefully we can get another 25. Again, just a reminder that I put the notes in the description, and I will see you in the next video. Be sure to subscribe.